Algebra 2, Lesson 24, Part A is fractional equations. And these are just equations that have fractions in them. And you could, like looking at example 1, you could add 3/5 to both sides. You could get common denominators for 3/5 and -1 and 1/4 and add them and then solve it. However, if you look down through the other examples, they get a little bit more complex. And for all of these that have a fraction in them, you can just kind of wipe out the fractions as your first step and then only have whole numbers to work with until possibly the answer. The answer might still be a fraction. But it's usually easier for most of us to deal with integers than with fractions. So to eliminate fractions in an equation, we multiply each term by what would have been the least common denominator. So looking at this first equation, we have as our denominators 2, 5, and 4. So the least common denominator for those is the same as the least common multiple of 2, 5, and 4, and that would be 20. So what I'm going to do is first rewrite this equation, changing mixed numbers into improper fractions, and then multiply all three of the terms in this equation by 20 over 1. All right, so my first step, I have 9/2 x minus 3/5. I'm going to leave a little space so I have room to show, like write my 20 in there. And then this would be 5/4, -5/4. All right, and I'm taking, again, LCM of 2, 5, and 4 will be 20. So I'm multiplying 20 over 1 times each of these fractions. Okay, now reduce these. I'm going to cross cancel. 2 goes into 2 and into 20. And that's giving me 90x. And here 5 goes into 5 and into 20. So then I have a minus 12. 3 times 4 equals 12. And 4 goes into both of those. And that gives me a negative 25. Integers, much nicer to work with. So now I add 12. And over here I have 90x. And then these are opposite signs, so I subtract, keep the sign of the larger one, divide by the coefficient. And that doesn't reduce. X equals negative 13 over 90. And I could put this back in the original, and I'd prefer the version that's got the improper fraction to check it, but I'll save you time. We'll try to keep this video short and sweet. All right, so that is example 1. There was a fraction for an answer, but we didn't have to deal with fractions in our work. Okay, now in this one, I see these fractions again, and now I have 5, 2, and 3 in my denominators. So it looks like it's going to have to be 30 this time. And boy, if I would have left some space, I'm just going to write 30 over 1 right here. That's not very nice, but 30 over 1 there, and 30 over 1 here. All right. Now, 5 goes into 30 6 times. So I have just 1 in the denominator now. What I've got now, though, is 6 times this whole numerator. So I'm distributing. 6 times 4 is 24. So I have 24x plus, and then 6 times 2 is 12. On the next term, 2 goes into 30 15 times. Okay, I don't want to forget my minus here. And then I have 3 times 15, which is 45, equals, and then 3 goes into 30 10 times. That's just 1 times 10, so 10. And then I will go ahead and add like terms here and then solve it. So 24x, it's going to be a minus because the larger one's negative. 5 minus 2 is 3. 4 minus 1 is 3. Okay, so 24x minus 33 equals 10. Add 33. Okay, I'm going to go over here. 24x equals 43. Divide both sides by 24, and that's it. That will not reduce. Okay. And again, the answers might be not very pretty, but at least we didn't have any fractions we had to work with. That part was pretty easy. Okay, now we just have two fractions in example 3. And so we're going to have 14 for the LCM. So we'll multiply each of the terms by 14 over 1. Over here I'm just writing times 14 because integers. Okay, so 2 goes into 14 7 times. 7 times 3 is 21. So we have 21x for the first term. And then 7 goes into 14 twice. We're distributing that too. 2 times both of those. 8 times 2 is 16 minus 4 times 2 is 8. So 8x equals 42. 14 times 3. Add like terms. 21 minus 8 is 13x plus 16 equals 42. Subtract 16. 13x equals, okay, 12 minus 6 is 6. 3 minus 1 is 2. Well, this one's coming out nice. X equals 2 on this one. And again, we could put 2 back in place of both x's in the original just to check it, make sure it comes out true. But again, I'll save you time on this video and skip that, let you do that on your own. Alright, then there we go. We're on to part B, which is about overlapping triangles. Okay, so for this, we're going to have to fill in some numbers on our little drawing because there's supposed to be an X and a Y over there and a few numbers. And then I'll show you. So we're going to have here a 4 and then a 6 down there, 7x, and oh, there's a 9 there, and then y. Okay, and one other thing we're being told on here is that that angle is congruent to this one. So here's our triangle, all labeled. And what we have here with these overlapping triangles, these triangles are similar. If you recall, that same shape, just different size. Move this over just a little. Okay. So first thing I'm going to do, so that I don't get mixed up on what number I'm using, is redraw these triangles. They don't have to look the same as the ones in the original, just two triangles that are similar to each other. They look a lot alike. Okay, and I'm putting that congruent angle right there, just like it was on these. And this top triangle, the small one, we have a 4, a 9, and a 7. When this one, the large one, this is 10, because you need to add those two segments, y, and then this side is x plus 7. Okay, now, I know these triangles are similar, even though they only gave us one set of angles that are congruent, because both triangles have that angle on top. Okay, this angle is identical to that one because they were both exactly the same right here in the original drawing. So because those two are congruent to those two, and every triangle adds up to 180 degrees, I know these two are similar triangles, and I can either do scale factor to find my missing numbers, or I can do proportions. Either one works. The book actually shows you both ways of solving this one, and I'm just going to do proportions. That's kind of my go-to method. So I'm going to show you proportions here, but if you prefer scale factor, you can try it out. Check it in the book because, again, they show you both ways of doing it. Now, when I do my proportions, it's a little nicer if the variable is in the numerator. So I'm going to start with this triangle on the right. And if I wanted to find, let's say, y first, I would say y over 9, because they're corresponding parts. And then for the rest of my proportion, I need to have, the other ratio needs to be no variable, all number. So I'm going to go to this, 10 over 4. Okay, I started with the one on the right, on the other ratio and the other fraction, so I need to start with the one on the right on this one. So 10 over 4, which would reduce, but we'll take care of that shortly. Now I either cross multiply or just multiply both sides by 9. You get the same result either way. Okay, this way might take a little less space. Now I'll go ahead and reduce that. 10 and 4 are both even, so 5 and 2. Looks like y equals 45 halves. Okay, so that's one of the things I was supposed to find. And then we need to find x as well. So now we'll take the right, the one that's on the right side of each of these triangles, x plus 7 over 7. No, the 7's do not cancel because this 7 is not a factor. It's being added to the x. So that over that equals 10 over 4, which we know reduces to 5 halves. I'm just going to write 5 halves this time. And then again, I can cross multiply or just take 7 times both sides. Those do reduce because those are just factors. They're not add-ins. They're not being added anything like that 7 was. On this side, we have x plus 7 equals 35 halves. Subtract 7 from both sides. Okay, and I'm going to write this as common. Did it again, didn't I? I'm going to write this as common denominators on this side. So 14 halves. That's equivalent to 7. All right. And then I have 35, well, right over here, x equals 35 minus 14, looks like that's going to be 21 halves. That's it. Here's our x, there's our y, that's all we needed to find. And again, if you would like to see it with scale factor, you should take a look in the book. That's all there is. Have fun.